fluids again. This is number 4 of our series here. Now there's some interesting stuff going on here, because the dose here is 30 milligrams, but it says per kilogram over 24 hours. In other words, this is 30 milligrams for every kilogram that our patient weighs, and obviously over a 24-hour period. And you notice here it also says frequency 3 divided doses. That's something to watch out for. So what have we got? We've got 30 milligrams per kilogram, and our patient clearly says here weighs 6.5. Obviously quite a little person. So our first thing to do is to multiply these two together to find out what the total amount of milligrams they are to have during the whole of the day, and then we can divide it up by 3. So here we go. We've got 6.5 as their weight, and we've got to give them 30 milligrams. So you don't have to put the naught in, you could just multiply by 3, but just for the sake of good order, I'll put it in. Don't forget we're multiplying by 30, not 3, so we put the naught in there. 3 5s are 15, carry 1, 3 6s are 18, plus that 1 is 1 9. Now don't forget also, if you're multiplying, look to see how many figures there are after the decimal point. In this case there's just one figure, so you remember this surely, go in 1, so your decimal point lands there. So we've actually got now 195 milligrams, so we've done 30 times 6.5 to get the total amount of milligrams that they should have during the day. But of course we want a single dose. It's 3 divided doses, so that's important to watch out for. So why not do that division now? Divide by 3. Let's give some room. I often put a decimal point and a naught straight after the figure to make sure the decimal point lines up. Alright, so 3's into 1 obviously won't go. 3's into 19, well 3 6's are 18, and we need to carry 1, and 3's into 15 will go 5. Okay, we didn't need the decimal point after that, we got a nice round number. So now we have 65 as the divided dose. We've just divided by 3, and now we want to sort out what we've been given. So we've been given here 125 milligrams, so that's the H class part, 125, so we've got need have, and of course we want the solution, which is 5. Again, I'm putting the 1 under here to remind myself that there's a top and a bottom to the fraction. So again, if you remember, the NHS, need have solution, is a way of looking at it. Now, we can cancel this down. A figure ends with a 5, can be divided by 5, so that should be fairly easy to do. So 5's into 125, I have no idea, but 5's into 12 will go 2, and then we carry 2, and 5's into 25 will go 5. Same above, 5's into 65, I don't know, but I know that 5 goes into 6 just once with 1 over, and 5's into 15 will go 3. We've got an odd number now, which is a pity, but don't forget that we can always cancel down across. Bearing in mind that, excuse me for a minute, that's the top of the fraction and that's the bottom of the fraction, and we can cancel down anything from either side, anything that's on the bottom with something on the top. And we can do this here. How many 5's are there? 1, and how many 5's there are 5. So we're now left with 13 times 1 and 5 times 1. So we've got 13 on the top, therefore, and 5 on the bottom. And this is, the last thing you've got to do. We've got to divide 5 into 13. Always remember, go upwards in your division. Remember the fountains in Trafalgar Square, they always go up. So let's go across here and do that where I've got some room. We've got 13 on the inside and 5 on the outside. I'm going to put my decimal point in there again as well, just to make sure it doesn't run away. So 5's into 13. Okay, well that will only go twice, and that leaves us that 3 over, and 5's into 30 will go 6. I think we've got there. We've got our 2.6. 2.6 what? Well, don't forget, it was in mils. It's in a fluid. So when you put the answer in, which is 2.6, if you can see it amongst all this other arithmetic, 2.6 mils. And that's it. Quite easy, really, wasn't it?